Good afternoon, professors and panel. I am the DMER student. My name is Lucy. My supervisor is Professor Kendall. My research topic is lightweight design and research of ship anchor machine based on the response surface model method. I will introduce my topic following this four parts. The first part is introduction, and then the research methodology. Third is innovation point, and then the research plan. For our background, as we know, the shipping is the most fuel-efficient and environment-friendly mode of the commercial transportation, facilitating approximately 19% of global commerce. But the rise of the transportation industry leads to the consumption of marine energy, and the energy consumption of ships is greatly related to their deadweight tonnage. The anchor machine is one of the most important deck machinery, and it plays a key role in both emergency operations and normal operation of the vessel, such as vessel positioning, assisting operation, and special landing. Anchor winch are standard equipment on most seagoing vessels, whether they are cargo ship, oil tanker, even the passenger ship, and so on. The global merchant fleet comprises hundreds of thousands of various types of vessels, and this number is constantly changing year by year. So now, the statement of our problem is the traditional design relies on the testing, making it very difficult to accurately determine the specific impact of the structural parameters on the performance. That's why it will prolong the research and development cycle. Anchor winch structures designed by the traditional method are often too heavy, vibrate more violently, and are not compact enough. It will result in wasting of the material and energy. The research on ship lightweighting is of great significance, mainly reflected in the following four aspects. For firstly, lightweight ship can reduce the vessel's weight, thereby decreasing the power needed to overcome water resistance during navigation, which leads to lower fuel consumption. Secondly, it will reduce fuel consumption. Lightweight ships emit less carbon dioxide and other pollution during the operation. This helps minimize the environmental impact of shipping and promotes the development of green maritime transportation. Thirdly, it often involves the use of new material and optimized designs, which can reduce the amount or weight of materials required during ship construction. Then it will lower overall construction costs. The fourth, it will comply with international regulation, such as the IMO, International Maritime Organization. The IMO increasing requirement regarding ship energy efficiency and emissions. The application of lightweight technology helps vessels meet these regulations, such as the Energy Efficiency Design Index, the EEDI. By adopting lightweight designs, ship owners can also ensure their vessels comply with the latest international environmental and efficiency standards. Then it will avoid the restriction or fines. In summary, The core objective of ship lightweighting research using response service methodology is to achieve weight reduction, fuel saving, and cost optimization by optimizing design and fuel efficiency while ensuring safety, performance, and regulatory compliance. The scope of ship lightweight using the response surface model includes the multidisciplinary optimization, new material application, and process improvement. However, there are limitations related to the model accuracy, computational complex, material cost, and technology expertise. This part is about the literature, which I referenced in my research, involved in the keywords such as response surface model, FEM, lightweight optimization. This part is my research methodology framework. The response surface optimization method for anchor machines is a technique used to optimize the performance of anchor machines by constructing and analyzing a response surface model. This model is commonly employed to find and improve the optimal operating conditions for complex systems. It will divide it into 4 phases. The first phase is determine the design variables and optimization objectives. And then the FEA model will transport to the second phase to generate the sample point. After that, we will establish the response surface model. The last phase is obtain the optimal solution of the objective function. This figure about the electric combination anchor machine is the physical model we will use to our research. Actually, this figure or this model comes from the real industrial practice project with approximately around tonnage of 21 tons. We will focus on the structural optimization of the anchor winch, particularly on the anchor chain wheel, a support frame, and the reduction gear, because these parts have a key impact. For example, the anchor chain wheel and the core component of the anchor winch. The design and material choice of the anchor chain wheel directly affect the operational efficiency and the stability of the winch. Its optimization is crucial for the performance and lightweight objectives of the entire system. For the support frame, it also plays a very key role to the impact of the structure. The support frame bears the loads from other components, and its structural design influences the overall strength and stability of the anchor winch. Optimizing the support frame structure can reduce material usage while ensuring adequate strength. The gearbox controls the working speed and the torque of the anchor winch. Its design optimization can reduce energy loss and weight, thereby enhancing the overall system efficiency. Okay, this is the design details about our research methodology. The first one, define objective and constraint. Actually, it will clearly identify the optimization goals, such as the maximizing load and the cost, and any constraints such as the operational limits, material strengths. And then we can select some factors and levels. For example, determine the key factor affecting anchor machine performance, such as the tension, material type, and choosing the different level of these factors. For the phase 2, it will design the experimental endpoint. Using the experimental design method, such as the factorial design or the Boxy or others to generate the experimental data. This process creates the experimental plan to vary the level of different factors and record their impact on the results. Okay, these 6 methods are all the ways to generate sample point. The selection of method for generating test points in response surface optimization depends on the factors, such as the problem's dimension, experimental budget, optimization objectives, and model complexity. For example, the 4-factorial design and the frictional factorial design are suitable for the simple model, while the central composite design and the box B are suitable for the quadratic model. On the other hand, the Latin hypercube design is more suitable for the high dimension. For our phase 3, to build the response surface model, we can develop the response surface model using the experimental data from the phase 2. This model describes the relationship between factors and the response variables, such as the anchor strength and the failure models. After we get in the response surface function, then how can we evaluate the fit accuracy? Firstly, we should view error matrix. Check the error matrix in the response surface results, including mean squared error, the MSE, and the root mean squared error, RMSE. Metrics are typically shown in the summary of response surface analysis. Then we can analyze residual plots. Examine residual plots to assess the distribution of prediction errors. The residuals should show a random distribution, indicating the quality of the model fits. The last step, we can check the fit index, review the R-squared and the adjusted R-squared values, which measure how well the model explains the data and its overall fit. This page involved the formula and equation we will use to evaluate the accuracy of the response surface or function or model. Actually, it have some knowledge about the theoretical part. Phase 4, optimize response surface model. Analyze the response surface model to find the factor combination that optimize the objective function. Optimization algorithms such as the MOGA or the genetic algorithms can be used to find the optimal solution. For the third part is our innovation point. Firstly, we will propose a multi-objective optimization method to reduce the stress peaks, avoid motor frequencies, and improve the economic efficiency of anchor winch while minimizing weight. Then we can convert the FEA model into the mathematical model by conducting FEA to generate sample data for response surface functions. The last point is determine the impact of the different structural parameters on the anchor winch mechanical performance to ensure effective structural design. This table is my research schedule. Actually, I have already started from April, and I plan to finish my dissertation before the March next year. Okay, thank you. Welcome the feedback and questions.